नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर आईटी जेई एंड नीट। दिस इज अवर प्रॉब्लम सीरीज फॉर जेई एडवांस. We are going to discuss the theory through problems. Hope this will be useful for all of you. I will request you to like and subscribe our channel.
Question number one is single correct. Let me read this question. This is one of the best question of chemical equilibrium, which is based on how to solve a problem when the equilibrium constant is very large. So let me read out the problem. At certain temperature capital T for a gas phase reaction, the reaction is given here. The equilibrium constant Kp is 12 into 10 to the power 8 atm. If Cl2, HCl and O2 are mixed in such a manner that the partial pressure of each is 2 atm and the mixture is brought into contact with excess of liquid water, what would be the approximate partial pressure of Cl2 gas when equilibrium is attained at temperature T, given the vapor pressure of water is 380 mm of mercury at temperature T? So when we are solving this problem, we can write that what is the initial condition. So we can write here that at time T is equal to 0, there is no water in the system. So there is no water vapor. And there are three gases, Cl2, HCl and O2, and each of them is present at 2 atm. Now suddenly this whole mixture, gaseous mixture, is brought into a contact of excess amount of water. And since excess amount of water is there, so this system is going to saturate with water vapor. On saturation, the vapor pressure of water is equal to aqueous tension, which is given here. So there is two equilibria in the system. One is liquid water is converted into H2O gas, and the other is this H2O gas is participating now in this reaction. So here we can say that now when we introduce water, so we can take another time T. At this time, now water is present in excess amount, and the vapor pressure of water due to aqueous tension at temperature T, they have given 380 mm of mercury, which is equal to half atm. So this is half atm. But the point is, water is not the limiting reagent. The limiting reagent would be Cl2 gas. So we can write here that this is the limiting reagent. And since we can write here at time T is equal to 0, if I calculate what is the reaction quotient for this reaction, the reaction quotient for this reaction is pressure of HCl gas, that is equal to 2 atm to the power 4. So we are writing Qp, and pressure of O2 gas is equal to 2 divided by pressure of Cl2 gas, which is equal to 2, and the pressure of H2O now is half atm, so half to the power 2. So if I simplify this denominator is equal to 1, and this is equal to 16 into 2 is equal to 32. So the value of Qp is 32, means the value of Qp is very less with respect to the value of Kp. So the reaction will go in forward direction. So, and we know that when the value of equilibrium constant is large, reaction will first go in forward direction, complete in forward direction, and equilibrium will establish from backward direction. So here again, if I write that after a very long time, what is going to happen? So at time T, when this whole system is introduced with excess amount of water, now at that time we can say that these are the partial pressure of the gases inside it. Now, when the reaction is going to completion, time T is equal to infinity, means the reaction is going to complete in forward direction because the value of equilibrium to the constant is very large. So here I can write that this is the limiting reagent, and according to balance reaction, when 2 atm pressure of this is going to decrease, then 4 atm pressure of this is going to form. Already 2 is there initially, so this becomes 6 atm. When 2 atm of this pressure is decreased, 1 atm of this pressure will be formed. Initially it is 2, so 2 plus 1 will be 3. So this is the pressure of HClO2. Since continuously vapor pressure is supplied, so the vapor pressure of water is the same, and that is equal to half atm. So finally equilibrium will establish from backward direction. So I can write that at equilibrium, the vapor pressure of water will remain same, that is equal to aqueous tension. And where equilibrium is established from backward direction, I can write 2x, and here I can write that 6 minus 4x, but the value of x is very small, so I can write that this is approximately equals to 6. This is equal to 3 minus x, but x is very small, so we can take approximation, we can write this is equal to 3. So this is the system at equilibrium state. Now, if I simplify this, these are the pressure at equilibrium. If I simplify this, I can write that Kp, which is equal to a very large value that can be written as 12 into 10 to the power 8 is equal to partial pressure of HCl to the power 4. So 6 to the power 4. Pressure of O2 that is equal to 3 upon pressure of H2O that is half atm to the power 2. And we have to calculate what is the pressure of chlorine gas at equilibrium. So I'm not writing 2x. In place of 2x, I'm writing pressure of Cl2 whole square. So from here, I have to find out what is the value of pressure of Cl2 at equilibrium. So that can be written as, if I take this on the left hand side, so pressure of Cl2 whole square and the other things on the right hand side. So this is equal to 6 to the power 4 into 3 divided by 12 is equal to 1 by 4, right? So I can write this is 1 by 4 and this is also 1 by 4 in the denominator, and this is now 10 to the power minus 8. So if I simplify this, 1 by 4 and 1 by 4 is going to cancel out. So pressure of Cl2 at equilibrium, we can write from here that pressure of Cl2 is equal to 6 square into 10 to the power minus 4, which we simplify, it is equal to 36 into 10 to the power minus 4, or we can write here that this is equal to 3.6 into 10 to the power minus 3 atm. So this is the pressure of Cl2 gas at equilibrium. So they are asking what would be the approximate partial pressure of Cl2 when equilibrium is attained at T temperature. So according to this, the answer should be C. So very nice question. Question number 2. This question is of simultaneous equilibrium. Simultaneous equilibrium means more than one reversible reaction taking place in the same container. So going through the question, following two equilibria is simultaneously established in a container. PCl5 in gaseous state will dissociate to form PCl3 gas plus Cl2 gas. Carbon monoxide gas plus Cl2 gas will form CoCl2 gas. If some Ni solid is introduced into the container forming NiCO4 gas, then at new equilibrium state. So already they are asking about new equilibrium state means already equilibrium is there in the system, and when we introduce nickel and nickel is going to react and form NiCO4, then they are asking that what is going to happen here. In place of nickel, they can also add iron here, because we know that when nickel is reacting here, same way we can say that when iron will react, so in place of nickel, they can also use this. We are studying these carbonyl compounds in coordination complex. So both are possible, right? So here they have used nickel, but we can also use iron for the same. So now if I solve this question, we know that when we introduce nickel, nickel will react with carbon monoxide, and carbon monoxide is going to consume because this reaction is moving in forward direction. So once carbon monoxide is decreasing in the system, means according to Le-Chatelier principle, this system will try to compensate this carbon monoxide. So it will move in backward direction. This system will move in backward direction. So there is no change in volume of the system. The moles of the CoCl2 is going to decrease. So definitely the concentration of CoCl2 is going to decrease. And because of that, we can say here that Cl2 moles is going to increase. So in this reaction, the moles of Cl2 is increasing, and there is no change in volume of the system. So the concentration of Cl2 is going to increase. So due to increase in concentration of Cl2, if we see about this reversible reaction, we are increasing the concentration of Cl2. So if we increase the concentration of Cl2, this reaction will try to decrease it. So it will move in backward direction. So if we'll move in backward direction, definitely we can say that the concentration of PCl3 is going to decrease, and the concentration of PCl5 is going to increase. There is no change in volume. We are predicting in terms of reaction is moving in backward direction. So moles of PCl3 is decreasing, moles of PCl5 is increasing. That's why it is happening. So now moving to the options, PCl3 concentration will increase. So this A option seems to be wrong. PCl concentration is decreasing. They are saying it is increasing. So B option is correct option. Moving to the C option, Cl2 concentration will remain same. Definitely, we don't know because in the first reaction it is increasing and in the second reaction it is decreasing. So which reaction is going to dominate, we don't know, right? So overall what is happening that there is a change in concentration of Cl2. Definitely it is not going to remain constant. So because of that, this C option is going to be wrong. D option, carbon monoxide concentration will remain constant. No, that is wrong. Carbon monoxide concentration is going to decrease because it is reacting with nickel, right? So D option is also wrong. So answer of this question should be B. Question number 3, before solving this question, because if you read the question, they have given vapor density of N2O4 at a certain temperature is 30, and what is the degree of dissociation at this temperature. So by looking this question, we are solving a question in which we need relation between degree of dissociation, average molar mass, and theoretical molar mass. So when we write the relation between, I can directly use the formula. We can calculate the degree of dissociation of a substance. Here in this reaction, what is happening that N2O4 is present in gaseous state and it is dissociating to form 2 times of NO2 in gaseous state. So this is dissociation of N2O4. So when we write the degree of dissociation of N2O4, I can use this formula directly. If we remember this formula, this is very helpful for us. M theoretical minus M experimental upon M experimental N minus 1. So here in this formula, theoretical molar mass means molar mass of N2O4 by the formula. So if I calculate what is the theoretical molar mass of N2O4, that is equal to 92, because 64 here and 28 here, it will be 92. And they have given the vapor density, and we know the relation that vapor density into 2 is molar mass. Vapor density is 30 means molar mass 60 means N2O4 is dissociating. So this is average molar mass of the system here. So this is experimental molar mass, we can write that is equal to 2 into given vapor density, and given vapor density is also experimental. So from here we got that this molar mass is equal to 60. So now what is N, that is important. When we are discussing N, we should know that what is N. N is the number of particles formed by dissociation of one particle. Like here, when one particle of N2O4 is going to dissociate, two particles of N2O will form, right? So on dissociation of one particle, two particles are formed. For this, the value of N is equal to 2. So now I can directly use this formula to solve. So if I'm writing here that what is the degree of dissociation, alpha is equal to theoretical molar mass of N2O4 is 92 and experimental molar mass is 2 into given vapor density. So that is equal to 60 upon experimental molar mass is 60. N value will be 2, which is important. So 2 minus 1 will be 1. So if I simplify here, we can write that 32 divided by 60, which can further be simplified. We can write that this value is equal to 16 divided by 30, or again we can further simplify, this is 8 by 15. So if I have to calculate what is percentage dissociation, I can write that this value is equal to 800 divided by 15. So if I simplify this, I am getting this value is equal to 53.333%, like that we are getting here. So from that we got the answer A. A is the correct answer for question number 3. Now some of the student in hurry can do an error, like we should be very careful when we are writing that. For this reaction, if I am writing that dissociation of ammonia, 2 times of ammonia in gaseous state on dissociation will form nitrogen in gaseous state plus hydrogen in gaseous state, 3 times of hydrogen in gaseous state. So if I have to write what is the value of N, we know that when 2 particles of ammonia is dissociating 1 particle of nitrogen and 3 particles of hydrogen gas is formed. So by dissociation of 2 particles, 4 particles are forming. So here the value of N is equal to 2, because by dissociation of 1 particle, 2 particles will form. Same way, another example is there where you can do error. Dissociation of sulfur trioxide, 2 times of SO3 in gaseous state on dissociation will form 2 times of sulfur dioxide gas plus O2 gas. Again, for this, we can write here that on dissociation of two particles, there is formation of three particles. So if I am writing what is n is equal to 3 divided by 2, that is equal to 1.5.